Hello, everyone. Welcome to this lesson today. Without much ado, we are going to be dealing with exploratory data analysis today. We have this exploratory data analysis. This is nothing more than inspecting, cleaning, and looking at other details of your data. This is very, very important before you undergo any data analysis or modeling of your data. You just need to know, um, you need to understand the data you are working with. You need to know what it entails. You need to know that all the variables that you will be working with are in the correct order or are in the correct format. You need to inspect the data, and it is from this inspection of the data that you can decide to do data wrangling. If you have a lot of data and you want to make other variables out of the variables you have, if you want to calculate some other variables before you use them in the main analysis, all of these are dependent on what you find when you are inspecting the data. So let's go ahead straight away and see what happens. The first thing you do is to import your data, right? Let's have it that way. Import your data. So this is simply um, using the read.csv file, and then you write the name of your data. You have to put that in bracket, write name of your data dot CSV. This means that you need to save the data in a CSV format when you are entering the data in Excel. Okay, so this CSV format reads only data that is in CSV format. There are other ways that you use to import data into R, but as a beginner, I just want you to start with this one. This is very basic and it's the most commonly used data importation channel, especially for small data like academic data, research data, on a low scale. But before this, you have to, you must know how to enter your data. You should get the link to the data. Okay, you should know where the data is. Basically, you can go through the file, all right, you go through the file and then check through, go all the way to what, go to directory, and then you click. You just need to set the directory before you can import any data into R. Um, you click and then probably, let's assume, yeah, you go to wherever your data is, and then you have it all the way. Okay, you have it all the way. But now we are not going to import data. We're going to use data that is already in R. So maybe I can have another video, another class to discuss how you import data and how you keep this so that anytime you come to R, you don't need to go back to your file, to your local file, before you access the data that you want to work on. That should be a later thing for us to do. But right away, let's try and get data that is in R, and we can use the data. You remember the iris data that we have been using all the time? I want us to still use that iris data now. But again, I want to let you know that you can have access to data. There are several data sets that are inbuilt in R, and there are also data associated with packages in R. Okay, there are different packages. If you install those packages, there are example data sets that they used to maybe optimize those packages. And yeah, so if you want to access the different data in R that is in base R, is in various, you just write data and then you click. Now you see all the data that are in R have been listed here. Okay, so you can choose any of the data to work with Now let's take a look. This is the iris that we have been working with, all right? Is Edger Anderson's iris data. We will continue to work with the iris data. And in this case, we will bring our iris data. So let me mute this one. We don't need to use it anymore. I just use it to show you. Let me now bring iris data. So we'll bring iris data. Now you see iris. Now you have iris data set. Let's name it explore. Explore, right? We name it explore. And you read. Now, if you import your data in R this way, this is how it's going to look. And except if you click this, it will bring it out for you in this tabular manner. You can also say print explore, all right? It brings everything out for you the way you want to. So either by just running the name of the data set or by printing the name of the data set, it gives you the same output. Okay. So right now, for me, the first thing that I want to see when I import a data into R is to know what variables are in the data, okay? And what are the classes of these variables? So using one function will give me the names of the variables, will give me the kind of data, okay, vectors that they are, that is the classes of all the variables. And yeah, to some extent, the function will also tell you a little about if the NA in the data. So let's try this. The first is, and the function is structure. The name is structure, but you use str as a short form. Okay, if you write str, you see compactly display the internal structure of an R object. If you click that and you write explore, this is what I was talking about. First of all, it gives you the class of the data explore. In the previous lessons, we talked about the different data types and data structure. All right. And you remember we talked about data frame as well. If you are confused about this, if you have not watched those videos, I recommend you go back to watch them and understand very well. All right. Okay. So we go ahead. So explore is a data frame. It has told us that it's what a data frame. A data frame is a data that has rows and columns and labels and all their observations. Okay. All right. So, and this data frame has 150 observations. What this means is that the data frame has 150 rows. Observations are the different records that appear on each row, okay? And it has 5 variables, and it's naming the variables here for you. Petal length, petal width, and species. These are the 5 variables. Most time, if you are working with data like this, you really want to bring out all the names of the variables, okay? So you can use the function names to say, to write explore, and then you can see that these are all the variables you want to work with. This is very, very important, especially when you are running model and you want to write the names of each of these variable or a particular variable. It's easy to make mistake, typographical error, and R is sensitive, very, very sensitive to those typos. So most of the times I just bring this function and bring out all the names of the variables I'm interested in, and then I just pick the one I'm interested in at a time and then put it into where it needs to be. Okay, so this function names gives you all the variables, but it doesn't give you the observations, the values under each variable. I hope you understand that. Okay. So let's go back to the first one, structure. What does this do? It's giving us the internal structure of the data, as you saw earlier on, and it is giving us the class of all the data, of all the vectors, all the variables in this data frame. The first one, sepal length, numerical, is saying it is a numerical variable. The next one, all of them are numerical variable except one, which is the species. And this is called a factor, all right? And the factor has three levels: setosa, versicolor, and that is, you see that it doesn't give a complete stuff. If you want to know the complete name of each factor, you can simply write unique, unique species, or explore, and you write species. Oh, sorry, I have not written it well. You write this, and then it gives you that. You see how the thing is now. It gives you setosa, versicolor, virginica, and these are the levels. It told you earlier on that they have what there are three levels of these factors. You use levels as setosa, versicolor, virginica. So it is the virginica now that was not shown earlier on. If you want to know all the levels, you just find out this. Okay. And this also is used to identify. I use this to identify if there are NAs or some noise in the data. Sometimes you can write you can write the same thing in two different ways, either using an uppercase in one or introducing a space, in one. Excel can be very funny. Sometimes that happens. And R will look at all those as different variables, okay, or different levels. For example, if I was to write Virginica under species, I was to write Virginica. This is a lowercase. It begins with lowercase. In one of the observations, um, I start with an uppercase. In this case, R will bring that one uppercase and make it the fourth level of this factor. So it helps me to identify if I have made mistake in writing the levels of each factors that in the data set. All right, so the other thing I try to look at in the data as we talk about data exploration is I try if the data is so much, some data can really be large. You cannot scroll down to know all the things you have in the data. For example, this one has 150 observations, 150 rows. You cannot scroll through all to see. So if you want to do a quick overview of how the data looks, you can just print using head, okay, and then you write the name of the data. It gives you the first six values of the data. I mean, first six rows of the data set, and then you can you can know how the data is arranged and all that. Okay, but then I can also increase this. Right, you can increase it. You see that it has given you like 20 now. Okay, I made it 20 and it has given me. So you can adapt this to a particular number of rows you want to see at a time. Okay, if you take all of this, you see how that looks. That is how that works. You can also look at the end of the data. In a very large data, you want to look at the end, you use the function tail, and yeah, you write tail and explore. It gives you the last six rows of the data. You see 45 to 50 are the last six. Let me bring it out and tell me to give me the last 10. Let's see what happens. You see that it gives you 45. Let's increase it to 20. The last 20, it should begin with four, yeah, begins with 31. and all the way. So you can do a quick review of your data in this way. Okay, most of the time it's easy to go by this way. The other one is called dimension. You want to know the dimension, retrieve or set the dimension of an object. Now, basically, you want to know the dimension of this of your data. And what does dimension mean? It tells you, okay, what is the length of the data and what is the width of the data. If you just imported the data and you want to know how many variables you have in there with a quick overview, you can just write that and say explore and write that. It gives you what? 150 rows and then 5 variables. All right, guys, so the other thing is that we're going to be looking at is the classes, the class of each variable in the data set. So we can say class, explore, and then dollar species. Now you need to make this an uppercase. Then you run explore not found. Okay, yeah, I need to run this again. Um, yeah, I just came into it, so I need to run it again. And this, so it's saying it's the class species is a factor. You remember previously I told you and I told you about all the the structure of the data. You can see that it's saying the class is a factor and this, but sometimes when you bring in a new data set, R will look at it depending on the way you have entered the data. R will look at strings as characters. So in that case, it would tell you rather than factor, it would tell you that, okay, species is a character. And in that case, you will have to what? Convert or coerce that data into a factor because it is a factor that is suitable for your modeling, not character. Okay, especially when you are looking at your response variable across different categories of a particular variable, you really need to convert that that variable into a factor. I am not going to import a new data, but in the case where you import a data and you see that the categorical variables is showing character, you need to convert it to factor. And it's simple. You just do um, maybe you name it as now I will just convert this factor into character and then convert it back to factor, okay, so that you will see it the way you are supposed to do it when your data is showing character instead of factor. So this is what I'll do as dot character, sorry, no, not there. I'm supposed to use here as dot character, okay. Um, okay, no, this is it. I'll just copy this and place here and then save as dot character. And it's still the same thing and place, and then you run. Now, if you run this, now if you check the class of this again, you will see that it has become a character. All right. So you can always interconvert between data, data classes. Okay. So instead of importing a new data that has character and trying to convert, I'm just showing you this so that you can do that. You can apply that to your own data. Now I'm going to convert this back to factor that we can continue with. Okay. So I will just edit what I have already. Instead of as dot character, I'll just say as dot factor. And it gives me, you run it, and I run it again and see how it has become a factor. One thing I need you to know is that that there is some kind of hierarchical, how do I call it now? This kind of overriding effect of codes in the case that the first code you run, okay, or the last code you run will override the previous code you have run if you are running the same thing. Now, I'll just give you an example of that. Here we have said that convert species to character, since we already saw from here that it was a factor. Convert it now to character. And when you convert it to character, you check it becomes a character. Okay. Next thing is you convert it to what? We convert it back to a factor and it becomes a factor. So this is why I'm saying this one, the character that you have converted before, now converting it to factor now has overridden that one that you have converted to character. Is that okay? So in this case, and you see that it is the same thing I am using here, the same data name I am using here, explo the species, dollar species, here explo dollar species. This can really be confusing. So for me, what I do is if I have things like this that I'm always interconverting between variables, you give the names of each of these variables. Is that okay? So in this case, you can just say character or species underscore character. Okay, so if you do that, now you are going to use this one, species underscore character. Species operator, not this. Let me see, species underscore character as a character. Let's see what happens there. Oh, sorry. It's underscore, not dollar. So I have this. So it is here. I write this underscore character. Now you check this. Now it is saying it is what? Character. Now, if you want to bring it back to um, um, factor, you just say species underscore factor. It writes, and then you check this one instead of writing dollar sign again. You get it? You just write, and it brings you back to factor so that you will always know the one you are using at a time. It really, really reduces confusions. All right. Okay, so the next thing we will look at in this data exploration is that the other thing you want to find out, we talked about earlier that you used exploration to know the details and the structure of your data. You use the exploration to know if there are NAs in your data. That is, if there are missing values in your data, you use it to also know if your variable is in the right class that you want to use, like the one we just talked about. It was in a factor, we converted it to character, and then we converted it back to a factor. Okay, so in that case, you know what your variable is and how you want to use the variable in your analysis. There are a lot of things you use exploration to do, and some can be really specific to the particular analysis you want to do. But generally, these are the ones that you just want to know that your data has, or you can convert between variables in your data before you proceed to the specifics. Okay, number one, you check for outliers, you check for any values, that is missing values, and then you also check the normality of your response variable. This is very, very important. Let's briefly look at this. So now let's use to see explore, let's write explore outliers in data set. Okay. So number one, if we have outlier in data set, a quick way to know this is just to use the box plot. Okay, the box plot. I'm just going to show you briefly. I can just say box plot explore. Let me this syntax. I'm not sure it's going to work, but let's see what happens. Explore dot separate. All right, so it's working, but that is not what I want, okay? I want all the data to be categorized according to the different categories. I'm going to use another syntax. we say sepal length, sepal dot length as a function of species, and then we write the data. The data is explore. Okay. Object sepal length not found. Now, this is where the problem comes, and this is where the names function is very, very important. You see that I must have written something wrong, and it's telling me that the what the object sepal length not found. Now let's check the names and see if I have written it correctly or not. I am very sure I have not written it correctly. Now you see that it is sepal length with a capital letter in the length. Now I wrote it with a small letter and R did not accept it. Say I didn't recognize that. Now here is it. We have our box plot. Okay. Uh, Outliers that we are seeing here. What is outlier? An outlier is an extreme value at the lower extreme or at the outer extreme, at the upper extreme. Okay, here we have Setosa, we have vesicolor, and we have Virginica. Now we have one outlier here within the Virginica subgroup of the species variable. You get it now? So here, when you see this kind of outlier, you can run your model. Sometimes you can just be stubborn to go ahead and run your model and then compare it, run your model with the data, with outlier still in the data set, and then run your model with outlier remove, and then you see what difference the data, the model brings. Most of the time, a removed outlier is going to give a better model fit, okay? Because extreme values will really affect the estimates of your model. Is that okay? So here we only have only one outlier in Virginica. For me, if I was going to run a model, I would consider that this outlier is not very important. What I mean is that it's not going to have a significant influence on my model variance or model estimates. So I'll just continue with it, okay? So that is how you find outlier. The next thing we want to do is, well, maybe I should explain something about this box plot for you, or maybe I should just leave it till later on. We can talk about each of these plots so that you can understand them in detail. Let's continue. But all that you know now is that you have an outlier here. It is actually away from the normal range of the group of the values. Now, this is a lower value and this is a what upper value, and this is the median. Okay, so I'll just stop there. We'll talk about it next time. All right, so the next thing is let's explore NA. Let's explore NA, which means it is what missing values. Missing values. Before we continue this, I want you to know something about missing values. Missing values can come in different forms. Missing values can be introduced as a result of non-availability of your record. That is to say, you went to the field and you are taking record, and at a particular point, you don't have the variable, the values to record. For example, you go to somewhere and you are administering a questionnaire, and you administer a questionnaire to somebody, and then at a particular point, the person did not answer one of the questions. Okay, so if you are analyzing that question, you will find a missing value. If they are too much, you will just learn how to deal with those missing values. Sometimes you remove missing values, and sometimes you leave them in the data and recode them. For example, like um, no response. Okay, so missing values can be really tricky, because one thing with removing missing value is that you are removing the whole of that row. Okay, the whole of that row in the data set. If you remove missing value, let me show you this. Let's quickly print explore. All right. If I have missing value at this point, if this sepal length was missing, okay, in this data, and I'm analyzing sepal length, I need to remove this missing value. But what it does is it doesn't just remove only this missing value for this sepal, it removes this row entirely. Okay, so that is why it is very, very important to know why you are removing missing value. And you also need to know when to recode your missing value and have them back in the data. Is that okay? Okay, so let's explore missing value. One of the functions is.na. Okay, you write is.na and then you bring the explo. That is, you are looking at the data set, the whole data set, and telling you for every variable, tell me if there are missing values or not in each variable. So what this function does is that it takes the whole data set and then begins to list all, checks through all the rows from 1 to 150 and tells you for each variable if there are missing values. In this case, it's showing almost everything false, but this is a very, very dangerous way of looking at missing values, because if the data is so large, you can't really tell if there is a false or if there is a true somewhere there. What I'm going to do is to sum up all the missing value in each column. So the function col sum, all right, col sum, then I'll tell you sum of the NA values in Xplore. Now it tells me there are no missing values in any of the variables. Now you see how that is. This is very, very simple compared to this first function. I hope this is getting interesting to you. So for this, you can really do this for each of your variables. So let's continue to the next one. Let's check the normality of response variable. What I mean by response variable is the variable that you are interested in that is changing with your observations, okay? And it is the variable that you are testing against other variable. That is to say, if species change, does sepal length change? So here, response variable is a sepal length. You are interested in sepal length, but you can't investigate the sepal length without reference to other variables. So while this one is a response variable, species is what? A predictor variable or an independent variable. Okay, so what that means that it is the one that is causing the effect in this sepal length. There is a kind of causal relationship between response variable and predictor variable or independent variable. Response variable can also be called a dependent variable because the values are changing depending on the changes in the names or the categories or the values of the predictor variable. Is that okay? And one key thing that we need to know about this is for us to show if the response variable is normally distributed. This is going to go deep. If I want to give detail, it's going to take much of our time, but simply I want you to know that when we talk of normality in statistics, it talks about how your data is distributed, and the data should also fit the analysis you want to conduct. In a nutshell, there is a standard for normality. And the standard for the normality is a bell-shaped curve. So I'm not going to really go into that. If you want that, I can give another lesson on that. I don't want to make this video very long, okay? But just need you to know that if a data is normally distributed, it's going to resemble a bell shape. Or the other thing is that a normally distributed data has the mean, the median, and the mode to be equal. Is that okay? So that is another way of saying it. But it's a lot of statistics going on there. I just need you to know how that is sharing. The normality of the data, the nature of the distribution of your data will determine the kind of analysis or model you will feed to your data set, okay, to your variable, the one you are investigating at a time. So we check, this one will tell us exactly what type of analysis we will carry out with the variable of interest, all right? So you check, the first thing I do is to use a histogram. The easiest way to do this is using a histogram, okay? For example, if I want to say the histogram of a sepal length, I want to see how sepal length is distributed as right explore sepal length. Now, this is it. This is um, this is the histogram of sepal length, okay? Now, if you want to know that the data is normally distributed, you can check like this. I told you it's a bell shape, right? A bell shape that goes like this and comes this way, okay? If you want to trace the outline of this data, it goes like this, all right? While a normal distribution is a bell shape that goes like this, it goes like this, it goes like this with tail, okay? And then you have it this way, where you have the middle as the mean, and then you also have the middle as the median, okay? Or looking at this plot or the histogram of sepal length, it is really, really not normally distributed. You see that it has some tail here. It is skewed to the right, okay? But sometime we could just try to confirm it. You can use an analysis, all right, an exploratory test to check to confirm if this is normally distributed, and it's called the Shapiro-Wilk test. Okay, Shapiro test, and then you bring this all into it. Bring this all into it. So Shapiro is saying that the data is significantly different from a normal distribution. You get it? I already told you about this, that this doesn't seem to be a normal distribution from the bell shape curve I showed you. Okay. Sometimes it can mimic it. It's not, it cannot, it should not be perfect. Okay. But with this, by messing this, you know that, oh, no, this is really not a normally distributed data. So you go back and then confirm it with Shapiro. Shapiro is saying, Shapiro-Wilk test is saying that the p-value is significantly different from a normal distribution. So our data is not normally distributed. Now let's quickly check the other variables and see if they are normally distributed. Let's have this sepal width. Let's have sepal width. Exactly. The way I'm saying this, before we enlarge it, same sepal width is normally distributed. Okay? Sepal width is normally distributed. It's just have one peak. You can see, right? You can see that the shape resembles the bell shape that we drew in the first place. All right? It comes this way, comes this way, it comes this way, it comes this way. Although it is skewed to the right, also skewed to the right. But this pretty much looks better than the previous one, right? It really looks better than the previous one. And even though it is skewed, I would argue that this data is normally distributed, okay? But we can confirm with the Shapiro test and see what happens. Okay, so let's go. Oh, sorry, I need to clean this. Yeah, you really need to clean that. It's staying on the screen, not on the plot. Okay, yeah. So now go. Now we go back. You go. And you go back. Now let's confirm this with Shapiro and see what happens. This sepal width. Exactly. So Shapiro says that the p-value is telling us that the data is not it's not significantly different from a normally distributed data. Remember, we are comparing it to our imaginary normally distributed data. Okay? Aha. So it's showing which is a bell-shaped curve. So this one is telling us that it is not what significantly different from a normal distribution. So it means that this one is normally distributed. And also you can choose what analysis to run with this one. All right. So this is how we can explore our data. There's a lot more detail to do. I mean, a lot more things to do in data exploration. Like I said before, sometimes you can go specific. You can check the homogeneity of variance. You can check the independence of your response variable. You can check, several other things to fit into the model you want to know. Okay, you can check the model fit even to that particular data. So all of those are part of data exploration that will give you or inform you about choosing a perfect model that fits your data. So I hope that we will continue with this. If you know that we should continue with this data exploration in detail and give you more other details, maybe specifics to several other data analysis, please just put in the comment section and we can move this to the next step. Thank you and see you. But please, before you go, share this, like it, and make your comment in the comment section. Let's engage ourselves. Thanks. Bye.